No, it's almost time. Good evening and a very warm welcome to our Blockchain Lab. My name is Adrie Wisman and I am co-founder of BlockchainLab Drenthe. The BlockchainLab Drenthe Foundation is a non-profit with the goal to spread knowledge, experience and insight in the field of distributed ledger technology under entrepreneurs, students, schools, governmental bodies, etc. We do research and development to increase our own knowledge about blockchain technology, and we are also involved in Interreg Project Bling, which stands for Blockchain in Government, where 13 partners from 6 countries cooperate in the field of blockchain. This is a monthly meetup, always on the 3rd Thursday of the month, and for obvious reasons online. This is the agenda of the evening. I am going to speak about what's going on in the blockchain space, some news, some scams, etc. After that, Jeroen Wester is going to talk about Merkle trees. Then we'll have a small poll. We would really like your feedback on how we would do future meetups. And after that, Danny Dreyfus will talk about developing on the Ethereum blockchain. And then we'll have an informal gathering. First, I have a service announcement. Everybody knows YouTube, you're here, but not everyone knows the chat function in YouTube. To communicate with us, you should use the window next to this small presentation. You'll have to log in with a Gmail account because YouTube, which is a Google company, does not allow for anonymous people putting text in a chat. But then please introduce yourself. We know where you're from and who you are. Ask questions, post remarks, please interact. Not only that, I have the next slide. After this event, we will go to Jitsi, and so we can see each other and ask questions and talk about a blockchain in general. As you can see, I'm doing this presentation on my own. I'm doing the production also, so you will see me pressing buttons and looking at screens. I'm in the middle of 5 screens, and I have the feeling I'm trying to set a new record for multitasking for males. I have to look at PowerPoint, Spotify, there I see our polling program, I have YouTube chat open, WhatsApp, etc. So bear with me if I start acting funny and sounding funny, because I have the YouTube stream in one ear and my guest speakers in the other one. Without further ado, let's go to our first segment. And our first segment is what's going on in the blockchain space. Well, we at Blockchain Lab are not really deep into cryptocurrencies. We think that cryptocurrencies are only a small percentage of everything you can do with this vast universe of all the things you can do with blockchain, but they are the most known feature of blockchain. If I go to my next door neighbor and tell him the word blockchain, he says, "Oh, Bitcoin." I said, "No, blockchain." Talking about Bitcoin is always our opening, and the last few months I've been talking about how happy these people are that have Bitcoins. Everybody is smiling, and that is because in the last months, every month I would have to report double-digit increases in value, and that's this monthly meetup also the fact. As you can see, our last meetup, Bitcoins were at $23,083 US, and yesterday evening the Bitcoin was at $32,950 US, and it has even been over 40,000 very short. So an increase in value of about 44%. So the big smiles are on the faces again. Here you can see a chart over the last year, what's been going on in Bitcoin. But these people who are smiling, most of them are in it for the money, right? To get rich fast. But Bitcoin is not the best cryptocurrency to do that. I here have another of the big five cryptocurrencies, Ethereum. Ethereum is the orange graph and Bitcoin is the blue graph. And I think you see where I want to go at. If you would have invested $1,000 US 1 year ago in Ethereum and $1,000 US in Bitcoin, then the Bitcoin part would have increased to $3,250 US. Whoa. But the Ethereum value has gone up to $7,550 US. So if you are into investing and speculating with your money, then Ethereum would have been a much better investment. Even looking throughout the year, right? The Ethereum people would have doubled their money on July 30th, while the Bitcoin people would have doubled their money on the 18th of November. So yes, Bitcoin has turned out to be a great investment opportunity, but you better put your money in Ethereum when you are into the biggest cryptocurrencies, right? There are lots of small coins which are very speculative and maybe have gone up a little bit more, but in this case, Ethereum is a very reputable cryptocurrency. So far, cryptocurrencies. Talking about distributed ledgers, then blockchain is popping up everywhere, right? So also when we are looking at the pandemic. And what you see here on the screen is a blockchain monitor for COVID vaccine storage. This is a company everywhere which is handing out sensors, temperature sensors, to see if the vaccine is stored correctly, right? They put all these temperatures on their chain so you can follow the exact temperature readings from all these sensors for all these vaccines. So this is a blockchain application combined with Internet of Things, where we use blockchain to make these vaccines safer. And they do that on the Hedera chain, the Hedera graph, so to speak. So here you see a comparison between the Bitcoin, the Ethereum, and the Hedera hash graph. And you can see that the speed in which they can do transactions is 1,000 times higher than Ethereum and Bitcoin. The transaction cost is more than 1,000 times lower, and they have their transactions confirmed in a matter of seconds instead of a matter of minutes for Bitcoin. So I researched a little bit about this, and I'm going to look a bit further. This is a proof of stake consensus, so it's also very energy efficient. This is what they call a third generation blockchain, Bitcoin being the first, because you could put your transactions on the blockchain, Ethereum being a second generation because you could put smart contracts on it, and this being a third, also being able to do smart contracts, etc., but with proof of stake. Now, another application of blockchain in the field of the pandemic is this application where IOTA is being used in an application which they use at Frankfurt Airport. With that, you can prove that you had your COVID test, which was negative. So there's a company that uses IOTA as a storage. They use it in combination with Merkle trees, which Jeroen is going to talk about. And they store the lab findings, the lab results, and the storage is done by the laboratory. And you get a QR code, and with that QR code, you can go to the airport. It is scanned by an official, and it will show this green screen to prove that your lab results were negative without giving your personal information and proving that you were healthy. This is one of the many practical applications of IOTA. This same company, UBirch, is using this also to store temperatures, body temperatures. They have, I believe, more than 9 million data points already of women putting their core temperature on the blockchain through a sensor for fertility tracking. Blockchain is also entering the rest of the technical world when it comes to employment. This company, which you see here, is looking for IT specialists, and as a matter of assessment, as a test, they send all their potential employees a hard disk with cryptocurrency on it. If you are able to crack the device, if you are able to get access to the key, you will get a number of bitcoins in the value of around 5,000 US dollars, which you can use to come to their headquarters in America and have a talk about working for them. So here you can see that they are using bitcoins in a completely different way, but to test how intelligent their potential employees are. Then one of the points we always have in this segment is talking about scams, and not because we like scams, but we hate dumb people. Let me explain. Here on the screen you have our announcement on LinkedIn, and my good friend Danny Drenthe put a small remark under my message. People, please send me your Bitcoin private keys so I can prepare for this presentation. Now, you will probably say, who is dumb enough to send Danny his private keys? And I haven't asked him if anybody did it, but there are people who are dumb enough to do so, right? I have here an example of Trezor. Trezor are these cold storage USB keys. Some people have ledgers, some people have Trezors, etc. Well, there was this guy, not from Trezor, who put an application in the App Store and in the Google Play Store with the logo of Trezor, and people could download that app and put their private keys in the app, so they would have them stored there also next to their USB key. You can guess what happens here, right? So if you put your private key in there, it is sent to the crook, and he will use your key to extract all your funds. And you will probably say, how can people be so dumb? But there are many people who are this dumb. So please be warned for this kind of scams. Google has scanned their store, and there were about 200 different apps that have the same category, that they are like phishing attempts to get your keys, your passwords, to extract your funds. Now, last month there was a little incident at Ledger. People saw the message that their information was captured from the database from Ledger, so your name and address, phone number, even credit card number were stolen. And there was lots of panic. People were afraid that their funds were gone. But if you know what is happening, that on the ledger is only the key, nowhere else. Nobody can get to your key if you don't give them access. So this person, Andreas Antonopoulos, who is an expert in Bitcoin and distributed ledger technology, set up a number of webinars. In fact, it was one big webinar of 2 hours, which he cut into pieces, with which he then would explain everything around security and Bitcoins or your cryptocurrencies. So I highly advise you to look at YouTube and find these webinars explaining everything there is to explain, and that you don't have to get into panic, because as long as you keep your ledger in your pocket safe, nobody will steal your funds. Okay, this was my last slide for our what's going on in the blockchain space segment. I haven't seen big questions in the chat, so let's go to our next segment.
Merkle trees, should you know about them? My name is Jeroen Wester, one of the founding members of the BlockchainLab, and tonight I'm going to talk about Merkle trees. Spoiler alert, yes, I'm going to answer this question. Okay, what are we going to talk about? Well, of course, we're going to talk about the reason why Merkle trees exist, and how they work, how they are used, and a very brief conclusion. Yeah, the conclusion is only one slide. So if you made it to the conclusion, there's only a limited amount of time left. Okay, why are there Merkle trees? Then we have to talk about sets, about data collections. And what these Merkle trees do, they show proof that two or more data collections are equal. And this sounds a bit like a trivial problem, not very important, but I can assure you that there are in many cases in the world in which the proof that two or more data collections are equal is very, very important. And the big thing about Merkle trees is that it can not only do that, show that proof for small data collections, it is even better for very large data collections. So using these Merkle trees, you can prove that two very large data collections are indeed equal, the same, contain exactly the same data. Where is this used then? Well, it is used for sharing things. And the developers among us, they all know, they probably know something like Git, which is used to share code. Developers develop code, of course, and they want to share this code to a central repository, for instance, and they want to make sure that the code that they have in the central repository is exactly the same code as they have on the local machine. But you also might know BitTorrent, for instance. BitTorrent is used for peer-to-peer file sharing, and BitTorrent, illegally you can download all kinds of stuff like the latest movies and those kind of things. And what you want to make sure is that the movie that you have downloaded does exactly contain the same bytes as the movie that is on another machine. And again, Merkle trees are there used to make sure that what you have downloaded is exactly the same as that is in another place. And the latest example, the last example on this slide is sharing ledgers. So now we are in the blockchain domain. So imagine that you have a network of all peers connected, all nodes connected, and you want to make sure that every node contains exactly the same ledger. Then Merkle trees are used to prove that these ledgers in this network are exactly the same. Well, here's a brief example. This is a Git example, and here you see two columns. The left contains code, and the right contains code, but you can see that the code on the right contains, and that is printed in green, a little bit more code than the repository on, or the code on the left. Well, these differences, this is something that you can prove with Merkle trees. And I'm going to explain to you very briefly how this works. How do they work? And to show you how this works, we're going to do a very small example. Imagine that you are a part of an EU summit organization committee, and your task is to take care of the guest list for this EU summit. And there are a number of guests invited for this EU summit, and you see them here on this slide. These are all prime ministers of European countries. And you might know some of them, probably the prime minister of your own country. You might not well know all of them, but they are from Finland, from Denmark, from Belgium, from France, Germany, Holland, and of course also the UK. What would an EU summit be without the UK? Okay. Then there is, on the bottom right, there is another man, and he doesn't know who these people are. We come to talk about that man on the bottom right a little bit later on. The task that you have in this example is to make sure that every participating country has the same guest list. Okay, now imagine that there are two guest lists. We have the guest list of the Netherlands and we have the guest list of the UK, and they contain a number of names. In order to organize the EU summit in a very proper, decent, nice, well-organized way, would be that every guest list for every member contains the same names. And your task is to make sure that on every guest list, the same names appear. Well, your boss comes to you and says, this is a very important task. You have to check every guest list and every name has to be the same. And you, very serious person, you take your task very seriously and you start comparing. You start at the top and you work yourself through the list to the bottom. And then, to your surprise, at the bottom, you find that there's a difference. The name Merkel is spelled in the wrong way on the UK list, which is not quite very, that's a common mistake, I think, in English-speaking countries. They are a bit dyslexic, I think, with the E and the L, so the E and the L got switched. So you return to your boss and you say, I have found a mistake. The UK list contains the wrong name. And your boss, he is satisfied with you doing this job. I say, well done, you found a problem. These lists are not exactly the same. But your boss is not that satisfied because he tells you it took you a rather long time to find a difference. You're a bit surprised. I immediately started with the task that you gave me, and I worked myself through the list, and at the bottom I found the mistake. And your boss asks you, okay, in how many steps did you find a mistake? Well, this list contained 8 names, and it took me 8 steps to find the mistake. Okay. Well, that's too long. Could you go back? Your boss tells you, could you go back and try to find a different approach that takes less steps to find a possible mistake when you compare 2 guest lists? So you return a little bit worried, how should I do this? But then suddenly you remember that you had a crash course on hashing. And that might be a very good idea. You remember from this crash course that you could enter data and that this data would be hashed. And the hash would reflect exactly the data that was put into the hash. So when there is a small difference in the data set, it would result in a different hash. That's the thing that you remembered of the course. So you think, when I compute hashes of both lists, then it must be possible to see if lists are the same or that there is a problem, that there is a difference between these 2 lists. And this might be a very good idea. So what you did is you entered both lists separately in the hash calculator and you computed a hash for both lists. And in this slide you see that hash in a shortened version. You see only the first 5 positions of that hash. And immediately you see, okay, there is a difference between the 2 lists. Because of the name Merkle spelled in 2 different ways in these 2 lists, the hashes of this list result in 2 different hashes. You are excited and you think, I've solved the problem. I can really fast see how, if there is any difference. So you return to your boss and you say, I have found a solution for the question that you asked me. We should use hashes in order to see if the 2 lists are exactly the same. And your boss asks you, okay, but how should that work? And you explain them the story that I just explained to you. And you say, okay, when you compare these 2 hashes, you see that there is a difference. But then your boss asks you a very good question. And he asks you the question, how long does it take you to find the difference between the 2 lists after you have seen that the hashes are different? And you look at the list and you say, it takes me 7 steps to find the difference in this specific example. Because you know that there is a difference, you only have to go to number 7, De Croo, Prime Minister of Belgium, by the way. And when you know that De Croo is in these 2 lists the same, then you know that it is the last. So you win 1 step. Your boss said, okay, so this is a very complicated story about hashing and all these things. And the only thing that you could achieve for me is reducing finding the error with 1 step. That's not good enough. You have to go back to your drawing board and you have to come up with a better way to reduce the number of steps to find the difference between the 2 lists. So you return to your hashing course and you think, okay, I might be able to do this in a different way. What I also could do is I could not hash the complete list, but I could hash parts of the list. And when I hash parts of the list, I could also compute the hash of things that I hashed before. And now something else appears. Now a hash tree appears on your screen. So you take your task very seriously, and what you did, you computed the hash of Marin and Solberg, of Rutten and Johnson, Macron and Frederiksen, De Croo and Merkel. And what you did after that is that you took the pair Marin and Solberg and Rutten and Johnson, and you computed a new hash out of these two underlying hashes. And then you work yourself up to the top of the tree. And when you compare these two trees now, you can see that the top level node of this tree contains different hashes. So that must mean that these two trees are not, that the underlying data sets are not exactly the same. So you return to your boss. You say, I've done my homework. I've come up with a great solution. And it's called a hash tree or a Merkle tree. And but your boss said, okay, cool. I don't want to know the math behind it. Just explain me in how many steps can you find the difference between the two guest lists. And you say, okay, now I can find, after that I have decided that the two top level hashes are different, I can find where the problem is in 3 steps. And that is going through this binary list to below, and you see, okay, when the problem is in the pair decoder Merkle, okay, and I have to compare the co, that's the same, okay, then it has to be Merkle. So that's in 3 steps. Very, very, very cool. So your boss is now finally satisfied to say, well, you are my favorite guest list keeper. With you in control and command, every guest list will be the same. So please continue. I have a lot of faith in the method that you found. And your boss tells you also, but suppose that I have a guest list that is not 8 persons long, but is 1 million people long. A bit of a strange guest list, I agree. But will this work also? And you say, well, it will even work better. If the number of entries in your list is long, this approach reduces the number of steps enormously compared to manual pairwise comparison. I have to go from Marin, so all the way down. When I have 1 million entries, it will take me forever. With Merkle trees, that becomes very much exponentially shorter. Okay, now who was this strange man in the beginning, these photos? We have Angela Merkel, of course, from Germany, and we have Ralph Merkle. He is the inventor of Merkle trees. And he even patented the idea of Merkle trees in 1979. I believe the patent holds no longer, so we can all use Merkle trees for good. And he's also into cryonics, I learned a few days ago. And cryonics is, I believe, is the idea that you can extend life by freezing yourself in a kind of freezer and then defreeze yourself, and then hopefully you will be still alive. I don't know much about it, but his work on Merkle trees is very, very, very important for things like Git, BitTorrent, and of course blockchain. Well, how are they used? Well, here you see a number of commits made in a Git code sharing development system. And you can see that these hashes and hash trees underlying that are used to see if code is exactly the same in 2 different places. You can actually see parts of the hashes of the branches that you committed when you look in your, for instance, GitLab or GitHub or something like that. Very, very convenient. In BitTorrent, as I explained before, you want to make sure that files that you share with another peer are exactly the same on all the computers in the network, in the peer-to-peer network, and you can do that with Merkle trees. You can even find where the things are different, so that you have to do some download at a certain part in your in the files that you shared. And then you can also use these Merkle trees to see where the differences are. And of course, in blockchain networks in like Bitcoin, Merkle trees are a very important part of the truth-keeping mechanism. And here we have one of my favorite thinkers about blockchain-related technologies. And he say, well, okay, Bitcoin is not unregulated. It has strong regulations because they are in software, in an algorithm, and it is therefore uncorrupted. Why? Okay, it's a very interesting thought. But why are they uncorrupted? Because of the use of Merkle trees, you can prove that the data that is distributed over all nodes is exactly the same. So your claim that you have 50 Bitcoin, while the rest of the network thinks that you have 5 Bitcoins, cannot be true, because the rest of the network will say, he is lying. That's not true. Don't believe him. He can say that he has 50 Bitcoins, but we can prove that he has 5. And that's cool. Okay, the conclusion. And then we'll wrap things up. Okay, finding differences between data collections or data sets, I'm not very strict on that, what it is exactly, can be efficiently done with hash trees or Merkle trees. So in large data sets, the amount of steps to find the differences between these two data sets will decrease exponentially when you compare it to one-by-one comparison. So as I stated in the previous slide, Merkle trees are a very important part of the truth-keeping mechanism in a blockchain network. Okay, and now answering the question, should you know about Merkle trees? Now, it's not really necessary that you know about Merkle trees, but to know about them and to know a little bit about the background of these, it's no burden. It's actually quite cool. And it didn't take too much of your time, so hopefully you find it very interesting. Thank you, that was it.
Okay. I didn't see any questions, and I know Merkle trees are pretty, let's say, dry and theoretical, but they are really very interesting. And we all know this use case of a girl a little bit under 20 going to the liquor store, and she would have to have identity on herself, because otherwise she wouldn't get a bottle of wine. She would not be able to buy that. She would have to prove that she is of a certain age. Well, that's all the GDPR discussion is about, right? Not sharing all the information on the ID, just sharing that you're over 18 or over 16, and the rest of the information should not be available to the guy working in the liquor store. You can do a very nice trick with Merkle trees with that, right? You only share the fact that she is over 16, and the rest of the information is hidden in a Merkle tree, and you only share 2-3 hashes, and with that you can prove that this identity is you and that you are over that age. Let me show you. I see a question of Luke. Can Merkle trees work on data that cannot be sorted? Absolutely. I'll improvise a little bit. Let me see. I'll get my paper. I'll explain the trick, and that is also the answer to Luke's question. Let's say I have here a personal data. This guy is called Robert. Is this readable? Yes. De Vries. And he lives in the Stationsstraat, number 19. Postcode is 7888 AX in Emmen. And he is over 16. And this information is checked by the municipality. right? They calculate the hash of all these items, and then they store the Merkle root on the blockchain as a certificate. How they do that is what Jeroen just described. You take 2, calculate a hash, take 2. You see that information is not sorted. It's absolutely useless to sort it. Hash, hash, and the Merkle root hash. Now, Robert has been to the gemeentehuis, the city hall, and they stored this hash for him on the blockchain. So he goes to the liquor store and he wants to show, without revealing all his information, that he is over 16, right? Now, normally I would take all these hashes and only disclose that he is over 16, but I would have to make a large QR code which has all these 7 hashes in it plus over 16. And when that is calculated, then it should be the same as the hash stored by the municipality. Now, with a Merkle root, it's a lot easier. I'll take another color. He shares that he is over 16, data. He also shares this hash, and this hash. Because with over 16 and this hash, he can calculate this one. With that and this one, he can calculate this one. And with this one and this one, he calculates the Merkle root. And that Merkle root is the same as the one that's stored in the blockchain by the municipality where he lives. And he shares, I'm over 16, without revealing the rest of the information. He only revealed 1, 2, 3 numbers, right? So in this way, it is possible that he wants to prove to someone else that he is living in Emmen, or that he is living in a certain postcode. He can only reveal that small piece of information with a few other numbers, and it is proved. If the data is not sorted, how does the tree ensure that the next element is placed on the left node and not on the right node? How is that made deterministic? You don't have to. You only have to know the structure of the record. The same Merkle tree that you see here is, when I put it in a different direction, used to prove that a certain transaction is in a certain Bitcoin block without transmitting the whole block. Only one transactions, a number of hashes, and then you can calculate the Merkle root, and all the other transactions are not transmitted, right? And this is only 8 pieces of data, right? And I only have to send 1, 2, 3 extra hashes. But if I have 1,000 transactions, I only have to send 8 or 9 hashes to prove any of these transactions exist in that big database of 1,000 transactions. How can we convince the user of this? He knows nothing about Merkle trees. Sean, it's very simple. The user doesn't know anything of this. It's under the hood. It's a way of using your application, and the application wants to say to a person or another database that the information I have on my phone, for instance, is this, and I can prove that it is true without sending the whole database, right? I don't want to send all the personal information, right, to calculate the total hash of it and to compare it. No, I just want to minimize the number of data that I send. So there's lots of nice tricks, right? These guys, Uberge, that have that app which is used in Frankfurt Airport, they do not store every lab result on the IOTA tangle. They take a block of 1,000 lab reports and they store the Merkle root, just one value. And when you go to the airport and you show them your QR code, then there is your test result and a number of other hashes, and they will result in the same hash that is stored, that single hash that is stored on the chain or on the IOTA tangle in this case. Right? So you have the possibility to prove that a certain data record is present in a large set of data with the minimum amount of transmission. Okay, great. Are there any other questions? No, I don't see any. Okay, then we're going to our next segment, and that's the segment where I need your help. Let me show you what I mean. We've been doing this meetup for a number of years now, right? And we have a certain format. That is what you saw this evening. First, what's going on in the blockchain space, and then 2 topics. Danny will, right after this, explain a lot about developing on the Ethereum chain. So we have a few topics. Now, we would like you to help us and tell us what you would think is a good format. For that, I would want you to take your phone and go to menti.com, and I will do it here on my phone also. Go to menti.com, put in the code 5670299, or you can scan the QR code. I'll do it the old school way. 5670299. And then it will ask you which format you prefer. And I will tell you how this is going on. Answer A is the format we are using today. Small introduction in green, then what's going on in the blockchain space, 2 segments with topics, and some questions in the end. B is there is no what's going on in the blockchain space, 2 30 minutes topics and questions at the end. C is what's going on in the blockchain space, and let's say 40 minutes, 1 topic that we will present that evening, and some questions and answers. And D is what's going on in the blockchain space and just 1 long topic. In this way, you can have a lot of deep dive possibilities. So I will, well, somebody has voted already. I will vote also. Hopla. And here you can see what is going on. This is working. Great. Okay. 10 people have voted, and most of them say, well, the format we're using now is quite all right. And the other 2, nobody is for 1 long topic. Maybe the D possibility is what we could do in a hands-on session or something. Last year or the year before that, we did some hands-on sessions in IOTA or with smart contracts. And then you can have a special session only focusing on that topic. Okay, so it seems 12 people have voted. I will wait a little bit more. You see, you hear I have a very light music in the background. So I think this is our final value. Great. It's good to see that most of you think that the current format is very sufficient. I have one more question. One more question. Let me see if I can do that like this. Right, I'll go back to 1 and I will switch over my Mentimeter. Okay. Up till now, Jeroen, Danny and I sit together once a month and talk about which topics we are going to use for our next meetup. But maybe we are not the average meetup attendant. Maybe we are living in our own bubble. And maybe we think that Merkle trees are super interesting, and maybe you think they're not. So what I'm asking in the next question and the last question is which topics would you like to see in our meetups? And let me vote for that. You can give several. Let me see. Oh, there it says the voting is closed. That's not what we want. Hydra show results. Oh, great. Why does it say it is closed for voting? We don't want that. Why is it closed? Type, customize. No. Here. Now you can vote. And I'll put it full screen again. So if you say, I would like to more about IOTA. Right? More use cases. John, the number, you want the number on the screen again? Let me show you. Here. 5670299. You can also scan the QR code. Cryptocurrencies, smart contracts in real life. Would like to see some more examples on actual pilots that are blockchain based. Possibilities with blockchain, use cases, compare different blockchain technologies. For instance, Hedera, cryptos. Okay. So 1/3 is about cryptos. 1/3 is about use cases. Right, use cases and possibilities, examples. Okay. Use cases. How to understand what could be a good pilot when you're working in a government setting. Okay. Possibilities with blockchain. Examples of smart contracts. Great. Good. Well, then we know a little bit which route we are going to go in the future. right? Danny is going to talk about a smart contract in real life. Okay, in a real life, yeah, in real life. So that is one thing. Opportunities for consultant type, non-developer contractors, top 3 dApps, privacy. Great topics. That's something which you can work with. Okay, again, top 3 dApps, tokenization. We can do that. Blockchain in music rights, royalties, hit parades, etc. That's a nice use case. Implementation of cryptos into real settings, self-sovereign identity. Yeah, and implementation of cryptos, what that mean? Cryptos which are on exchanges, or for instance, we are planning to build an application here in our municipality where every house will get its own identity on the blockchain. So not the residents, but the house has its identity. And within that identity, all the sustainability properties of that house will be stored. Right? If there's a heat pump, if there is solar panels on the roof, etc., etc. And this house will get a wallet. And in this wallet, he will receive coins with which the residents can buy special lighting, right? A very energy efficient lighting and that kind of stuff. Why the house its own identity and not the residents? The residents will move. They will sell the house and go and live somewhere else. And the identity will stay, the wallet will stay with the house. So then you will have your own wallet, your own tokens, your own currencies, which is only valid at local retailers. Right? So that is tokenization. I don't know if that is what is called implementation of cryptos into real settings, but it's on the edge of both, I think. Okay, great, super ideas, and we'll see in our next meeting what we can do to provide something in that kind of field. Okay, then I'll go to our next presentation. Danny will talk about developing on Ethereum.
Hi there, guys and girls. My name is Danny Drenthe. I'm one of the members of the BlockchainLab Drenthe, and I'm a tech enthusiast. That means that I spend a lot of my time programming the computer, including blockchains. In this presentation, I will talk about a little bit about developing distributed applications using Ethereum blockchain. So I've prepared a little agenda. It starts with an introduction, then I try to give an overview of the playing field when you want to access the Ethereum network using software programming. I talk a bit about tools and products that are used during this exercise, and then we're gonna do some demoing where I can show you how the actual contracts work, and then it's time for a recap. So this is a pretty short but intensive story, and I hope you enjoy it and you will learn something from it. I try to give a realistic overview on how basic Ethereum development takes place. I will try to keep it eatable for non-programmers, but no guarantee it won't get messy. The focus of my presentation is on the main flow, and on the usage of the different components. It's not on the code itself. I will show how to create and publish a distributed application on the Ethereum blockchain, and afterwards you can brag about being able to develop on Ethereum. So, starting with what is exactly the Ethereum network. It's a realization of a concept that's called Web3, and that's basically Web 3.0, and that means some smart guys thought it would be nice to talk about a decentralized, secure internet with a lot of services, not only Ethereum, but also some other things. The other things I mentioned are, for instance, IPFS, which is about storing documents. It's about Bitcoin. It's about Polkadot, Zcash. It's about secure messaging called Whisper or Matrix. You have a thing called Swarm, which is a peer-to-peer file sharing service. And this way, Web3, including Ethereum, is like structured or modeled to make it easy to understand in which level or which area certain tools or protocols exist. You won't see this a lot in the blockchain world because it's pretty abstract, but it's nice to know it's there to get some grip on if you read something about different protocols or applications in this Web3 tech stack. So we're going to zoom in on the Ethereum network, which is, as you all probably know, it's a blockchain. That means it's a chain of transactions, and these are basically duplicated. That means they are distributed among different nodes, and together these nodes, they make up the Ethereum blockchain peer-to-peer network. So we have different nodes in this, and if we zoom in on one of these nodes, you can see that the only way to access them is using something that's called JSON RPC. And this JSON RPC makes it possible to talk to the blockchain, including the smart contracts and things like gas, ether, tokens, etc. Mining, transaction pool. Short recap, a client node. You have to have a node to access the Ethereum network. That means to access the network, you have to become part of it. You can either run your own node, aka a client, also known as a client. One of the clients that's commonly used is GetH, but there's a easier way. You can use one of the known node service providers, for instance Infura. That's the one we're going to use in this presentation also. And you can, there's on etherscan.io, you can do really basic actions on Ethereum. For instance, send transactions which you signed yourself. But that's really techy. So if you look at what's happening if you try to access a Ethereum node, you always start with JSON RPC, then you go either through GetH or using a node service provider, or one other option is use a local network, but that's not really distributed. That means that the Ethereum network will run on your computer. And from there on you can access the mainnet, that's the real Ethereum, and then there are a couple of test networks which I used for development. In this presentation I will use the Robston test network. If we zoom in on this picture, we see a thing that's called HD wallet, and it's not high definition, but it's the abbreviation of hierarchical deterministic wallet. But you can forget about it immediately. It's being used for construction of the address and the private and public keys. And I think we will talk about this in a future meetup. It's an interesting thing, including this protocol BIP32. So when you start programming a Ethereum client, you have to you have to take care of this JSON RPC thing, but that's very complicated. So there are a couple of libraries which make that easier, and one of them is called Web3 EAS. It's a JavaScript file which wraps all these JSON RPC calls in an easy way. So you can use, for instance, call like get balance that will get you your Ethereum balance of that account. There are two other that are commonly right now, ethers.js and light.js. So when you take a look at the actual application that uses the Ethereum blockchain, you always access the Ethereum blockchain using a Ethereum provider. For instance, MetaMask, and that's called the Web3 provider, and also called a wallet. So if you want to do something on your browser with a web application and you want to use Ethereum, you have to have a provider, for instance MetaMask, but also MyEtherWallet is also one of these Web3 providers. So you need a node. Since running your own node, that's very complex and resource intensive, it's much more easy to use a node provider like Infura. Communication is easily done with web3.js. Actually, MetaMask uses Infura IO under the hood to access the Ethereum network. So that was something I found out during the preparation of this presentation. So when we are approaching our demo, it's nice to sum up the tools that I've used. One of them is Node.js, very familiar, development framework using JavaScript. We use NPM, that's the tool that delivers certain libraries and packages for Node.js. We use Truffle, that's a tool to deploy smart contracts. We use MetaMask, that's to sign transactions and act as a wallet. We use Infura IO to act as a node service provider, and we use the Robston test network from Ethereum, and of course a little bit of React.js. Our first demo is about an old acquaintance. It's the Truffle suite, and in that suite there's one demo that's called Pet Shop, and this Pet Shop uses normally it uses MetaMask or a local network client like Ganache, but in this sample I've changed it that for the deployment of the contract Infura IO is used. So in this demo I will show you the basic pet shop tutorial, but with a little bit of changes in the way that the contract is deployed. When we deploy the contract, we use Infura instead of the MetaMask wallet. So I've also prepared the smart contract and the application JavaScript, so I can copy paste them during this presentation, so you don't have to watch a lot of my typing in the source code. So let's go. We start with installing Truffle. That's a good old one. It takes, of course, it requires the NPM package manager, and when it's installed, the next step will be creating the pet shop tutorial. It's a click and ready turnkey solution from Truffle. It uses the unbox command to to get the complete application to your local computer. So it takes a bit of time. Then it's there on your computer. It has some kind of predefined directory structure with certain fixed elements. And one of them is the folder with the smart contracts. And in the tutorial, an explanation is given about this contract, how it's built up, and what you should do. I've prepared it so I can copy it and place it in the contracts folder, just as the tutorial asks me to do. Then the next step will be Drenthe compile. It takes the smart contract and it generates a JavaScript file containing the interface when you want to use it from a web application. So now it's ready to migrate. That means it's ready to deploy to the Ethereum network. The smart contract is then placed on the Ethereum network. Since the standard tutorial assumes you use Ganesh and we use the Infura connection with Robston test network, I have to change the truffle config so that the Infura node service provider is used. And this I also prepared, so you don't have to look at my typing, and you can assume it's all done correctly. Then the next command you can give is truffle migrate, and what happens then are a couple of things. You migrate the smart contract, but during this migration it of course has to be signed, because things on the blockchain are done in the context of a account, and you have to prove that you are the owner of the account. So you have to have your special mnemonic, which is also on the line 3 in the truffle config. So this is like my master private key, which you can use for signing and placing contracts. So when it's migrated, you will see that the result step of the migrate is oh, I see, I didn't choose the Robston network to migrate to, so that's corrected. So when it's migrated, the contracts are prepared for deployment, transactions are signed, and at the end the transaction is offered to the network, and that means that all the miners will go to work, and they take a little gas from me to do the mining, and well, it takes a bit of time before the mining is done, so we can wait on that. It's not that much. And of course these since it's on the Robston public test network, you can easily trace the actions that are being done right now. So you can, if you have at the end the resulting transaction hash, you can look up which miner eventually signed your transaction and placed the block on the Ethereum network. You can also use the Transaction Explorer to look up your contract that's deployed, and you can decompile and take a look in the contract. So basically on every smart contract on the Ethereum network, it's possible to look it up and check its contents. So when it's deployed, I think it takes about 10 seconds from here. You can see on the first deployment from the initial migration, it takes 0.00038 Ethereum. And my adoption contract, which is a little bit bigger, it takes 0.04 Ethereum. But do know that this is on the test network, so it's not really Ethereum money. So it's all test Ethereum. So now the contract is deployed. You can, what I just told, you can look it up on the Robston Etherscan, and then you will find the contract. You can see, well, it's deployed. You can take a look at the bytecode. You can decompile it. Takes a bit of time before the network is ready, and then you can see what's the actual contract on the Ethereum Robston network. So that's very good. That goes like a rocket. If we take a look at the contract which I made, you can see it also has an address. So next step is building a user interface, because this smart contract is very usable. So you want to have an application from where you can control it. The pet shop tutorial has some basic application framework, but you have to do some changes in there just as a learning exercise. But for this demo I just prepared the app.js file, and I just copied it because I prepared it. You don't have to look at my typing. So all very interesting functions that are used to interact with the contract. And when it's if you take a look in the application JavaScript, you can see all kind of calls to the contract, like adopt and etc. And you can get all the accounts that have adopted dogs. So next part is that my deployment uses Infura, but the app still uses MetaMask. So for the running of the application, I still need MetaMask. It is possible to change that also to Infura, but for this demo, I used MetaMask wallet in the application. So if you are lucky and you have done all things correctly, you can type in npm run dev, and that will fire up the website, the application. And then you quickly saw the browser sync connected, which says it recognizes the Ethereum MetaMask wallet. And you can adapt the dog, and it gives you an estimate on what the costs are. And you can check that the network is correct. If you take the real network, you will lose your Ethereum. That's not wise. So I've adopted this first dog, and I can see it's spending right now. So once again, all the miners are busy. It goes really quickly, and then you can see that this dog Frida is successfully adopted. So that was our first demo. Now going on with the second one. And in that demo, we will change the adoption contract. We will add the name of the person who adopted the dog, and we will add a method to abandon the dog, which is pretty sad, but well, it can happen. After that, when we have adapted and changed the contract and compiled and deployed the contract, we can I've prepared a simple React.js app to retrieve the dog's name and at the same time my balance. And in this app it's possible to abandon the dog. So here we are again for our second demo. In this demo I will take the previous pet shop tutorial, and I will change the smart contract. I will make it possible to also add the name of the person who adopts the dog, and I will make it possible to abandon the dog again. Maybe you don't like him, or he smells, or he barks a lot, so you can give him to somebody else. That's very good. So the basic idea is that we change the solidity contract. The first contract only had two functions, adopt and get adopters. In the second version of the contract, I take care of storing the name of the adopter based on the ID of the dog you adopt. If you have an empty name, it will delete it. And the second function is abandon, so you can give a number of a dog, and with that the dog gets abandoned. And you can have the function get adopter name you can use to get the actual name of the person that adopted the dog. If you look at this application where you can call these extra functions, it's a React.js application. It uses, of course, the contract as being compiled by Truffle, and in here you will see the actual functions, but then in the JavaScript file in the way that Web3 can use it. I import the Web3 library called Ethers, which I mentioned in the previous part of the presentation, and I use the Robson Infura provider. My mnemonic is in there so that Infura can sign the contract with my private key, and I add some information about which address the Infura provider should use. And from then on I can call functions like get balance, and I can call functions on the smart contract like well, the abandon dog based on the dog number. So that's very easy. And then I made some little user interface where you can actually click on abandon. So if we start our modified Truffle web shop, Truffle pet shop application, you can well, from now on you have a number of the dog which is there. They are from 0 to 15, and then you can add your name, and then you can adopt. The second app, which was the React Native React.js app, I can start it up using React.js, and that one gives me a simple user interface to check the actual owner. So let's adopt the first dog with ID 0. It's not really responsive. That's no problem. Dog number 1 is already adopted, I see, because it has the adoption button disabled. So dog 0 is not owned yet. And well, I also did a little check on my Ethereum. I have a lot of money, so I can do some things. Dog number 1 is currently owned by Xander, and that's true because you cannot adopt dog number 1. Well, let me adopt, no, let me choose Adri. He will get this dog from me. So I will adopt, Adri will adopt this dog, and it takes a little bit of gas, and it also takes a little bit of time, of course, to actually mine this transaction and to make the registration in the Ethereum blockchain that this dog is actually owned by Adri from now on. And then I can check it, and it says, well, it's stored on the Ethereum blockchain that Adri owns the dog. Adri doesn't like him, so he abandons the dog. So this takes again a little bit of time to process the transaction. As a typical Windows user, very impatient, I will push F5 a lot of times to see if it's already done. So I can reassign dog Frida with number 0 to one of my other colleagues of the Blockchain Lab. Now it's done. So I can adopt it again, and then of course it will go to Jeroen. He doesn't like dogs, I think, so he will probably abandon it very soon. And you can see it's pending. So this time a lot of computers are processing difficult puzzles, and one of them is the winner, and he gets to place the block. Then you can check it, and there you have it. Jeroen, you have a dog now. So when we ended the demo, I changed the owner of the dog to Jeroen. And if you look into that transaction on that contract, you can see that the input data says it's Jeroen who received the dog. So that looks pretty okay. Our recap for this little presentation is we have created a D-app, distributed app. It's distributed since the storage takes place on a distributed network. Solidity is not that difficult, but it's powerful enough for basic programming, especially smart contracts. The different tools and APIs are in an evolving state, but in my opinion very usable already. You should not be scared of the command line. It's very useful to spend some time in learning how it works. Getting to know and using the different tools, that's not easy. But there's always BlockchainLab Drenthe to the rescue, so consider that an invite. Thank you, and I've placed some pointers and reference links in this presentation, so you can read about all my experiences with this technology. Bye-bye.
Okay, that was a lot of information. We'll put the links from the presentation on our website, like all the other presentations from past meetups. I presume you have some questions for Danny. So later on, when we are going to use Jitsi, then you can ask these questions to Danny, not to Jeroen, because he's walking the dog, but Danny will be present for sure. Okay, then the only thing left is for me to thank Jeroen and Danny for their presentation and tell you about our next meetup, which is going to be on February 18th, right? And there again is the link to our Jitsi meeting that we're going to go in let's say 5 minutes. Then I never expected to say these words. You see a subscribe button on YouTube. Please press it for us. We're trying to build a community. So if you press like and subscribe and that kind of stuff, then the next time somebody is searching for blockchain on YouTube, we'll get a little bit of better ranking, and maybe we'll grow this community a little bit more. That is all for now. I see no other questions, though, so no, let me get the other one. So I hope to see you in Jitsi. It's a very easy link. I'll put it also in the chat. meet.jit.c/BCLD meetup. I hope to see you there. Bye bye. Till next time.